Good morning, dear students. Welcome to this session on pre-stressed concrete. So, last session we have talked about sequence of anchoring. What are the steps present in the anchoring? Then we have talked about couplers, which are optional devices which will be used at the junctions. Okay. Then we have talked about grouting activity and the machine used for grouting. Okay, and this session we'll talk about an example, one or two examples, just to manufacturing post-tensioned members. Okay, so first example, let us see manufacturing of a post-tensioned bridge girder. Okay, which is taken from L&T. Okay, so post-tensioned I-shaped girder for a bridge manufacturing we'll see now. So the first photo shows the fabricated steel reinforcement with the ducts for the tendons placed inside. Let us see. So this is the I section that we are going to see, the manufacturing of I section. So fabrication of reinforcement is the first thing, and you can see this some pipe-like things that are being uh, inserted into this concrete. There are 5 such pipes. Those are called ducts. Okay, they are ducts. Okay, right. So this remaining reinforcement is untensioned reinforcement, or what we call conventional reinforcement. Okay, just HYSD bars. These are all HYSD bars. Okay, so these are just normal steel that is being designed along with the pre-tension steel. Okay, so what we call it's like a partially pre-stressed beam. Okay, because you have both tension steel and untensioned steel. Okay, right. So you have no fabricated uh, steel cage like with the untensioned steel, and also provision made for ducts provided for the HTS bars to insert. Okay, so this is the first photographs that you see. Okay, then the parabolic profile of the duct is for simply supported girder. Okay, that no, you can see the duct that is being provided has given a shape something like this. It's parabolic. As the photograph is taken from one end, it's look like unsymmetric, but it is perfectly symmetric parabolic shape. Okay, so this is something like this. Okay, so such ducts are being used here. Okay, right, parabolic, and for simply supported girder, why we use parabolic profiles of the duct, we will know with the discussion in the very next section of the topics, like in the unit 2. There is a topic called analysis of pre-stress. In that topic we'll talk about all these profiles, cable profiles and all. Okay, right. So for now, understand that for simply supported girder we'll use parabolic profile, okay, of the high tension steel. Right, after the concrete is cast and cured to gain sufficient strength, the tendons are passed through the ducts as shown in the second photograph. So just see the placement of tendons. So with the untensioned steel and ducts provided, and now end bearing plates inserted. You can see that these are the bearing plates inserted at all 5 locations wherever there is a duct. Okay, so with that reinforcement cage and all, the concrete is being cast and it is left for hardening. Now the concrete is hardened, ready for tensioning this high tension steel bars. Now you can see the tendons are being just taken through that duct from one end to the other. Okay, now these are ready for tensioning. The bars are HTS bars are ready for tensioning. Okay, these are HTS bars. Whatever are already available here, they are just now untensioned steel, just normal HYSD bars. Okay, that is in the. So what you see in this picture is concrete is being manufactured, poured, and then the hardening is done. Concrete is ready for pre-stressing. Okay, and the tendons are being inserted into the ducts. Okay, so that is what is this second photograph. Okay, so concrete is cast, cured, then it has got sufficient strength now, and the tendons are passed through the ducts. Okay, then the third photograph, tendons are anchored, pulled, okay, at one end and stretched at the other end by a hydraulic jock. Okay, so one end of this tendons are anchored by some anchoring device, maybe Fresinet or a Gifford system, whatever it is. The tendons that are taken through these ducts, one end we will fix uh, the anchoring device. The other end, say if the other end is anchored, this end we will take up the jacking operation. Okay, so that is what you see, stretching and anchoring of tendons. Okay, stretching will takes place only at one end. The other end, now we will have anchors. So you can see that these are being stretched and anchored, stretched and anchored. Stretching is going on. Okay, the hydraulic jock is being placed, then stretching is going on. Okay, so this is the final form of. The other two are to be done. They are waiting for stretching to happen. Only these three are being stretched. Third one to complete. Third one is in progress. Two are yet to be done. Okay. So this is the just a brief pictorial clear idea will be given to you in terms of this diagrams rather than line diagrams. If you see the real pictures of what is going on in the field, you will know what is it, what exactly we will be doing. Okay, in post tension. Right. Going for the next example, construction of a box girder for a bridge, and this is taken from Cochin Port Trust photos. The first photo, fabricated steel, the ducts for tendons to be placed. Okay, let us see that. So you can see all these ducts, okay, which are no, for the purpose of placing the tendons. Okay, right. So what you see here is the ducts, pipes like things. Okay, 3, 4, 5. So all these are being left for high TS, HTS bars to uh, uh, to pass through, right? Remaining steel that you see, entire steel, the bottom, the side walls, all that, the entire steel is just a nominal steel like HOSD bars, untensioned steel. Okay, right? These are the end blocks which are first cast. Okay, and remaining portion will be casted later. And once this is ready, the remaining portion will be made ready. Okay, because the end block is the one which will be taking care of these tensioning operation. Okay, this is the first photograph that you can clearly see that the ducts are left for the pre-stressing steel to be kept. The remaining steel that you see is only is just a untensioned steel, HOSD bars. Okay, so you have both the normal steel and as well as uh, high tension steel. Okay, right. So the top flange will be constructed later. So first photograph that you see, you don't have a top flange to be constructed. Okay, this is actually to be done like this. So that will be done later on. Okay, only the side walls and the bottom flange is done. Okay, so to complete this box girder, you need the top flange also. Second first photo show form work for in the pre-casting yard. So form work, how it will be, uh, form work will be. You can see all the tie sections are being kept as form work. Okay, not just the sheets that we will see normally in the buildings. Okay, so these are all eye sections because you are going to cast a heavy member. So to take care of that load, you have the uh, the truss like uh, the supporting system for this form work, and then anyhow those will be covered with the sheets again. Okay, so this is how the form work is. Now you can see the top flange is also being made ready. Okay, it was now the side face and bottom. Now you can see the high tension steel wires here which are being taken outside. Okay, so form work is shown here how it will be. Okay, it's like a very big yard, pre-stressing yard that you can see. Okay, right. Then the formwork for the inner sides of the webs and the flanges is yet to be placed. Okay, only for the outer side it is being shown here. Only for the outer faces. Okay, and inner face formwork is also is yet to be kept. Okay, then what next? The third photograph, a girder is being post-tensioned after adequate curing. Okay, so post-tensioning of a girder, the tensioning operation. You can see uh, one is done, second one is done, third one is done, and then fourth one is done. Two more are yet to be done. Okay, something is same here also. Two more are yet to be done. Okay, so tensioning operation is also being done. Okay, then the next photo shows a crane on a barge that transports a girder to the bridge site. Okay, and the last photo you can see the completed bridge. Okay, right. So this is a crane with a barge to take care of this transportation of this ready girder. So girder is box girder is ready for transportation, right? And we will now you can see this portion is being manufactured in the yard, then transported to the site, placed in the position over these piers. So something like this. So all these portions are being made ready at the uh, you know, uh, pre-stressing yard. Okay, this much of span you can see that is being made ready. Just transport, place it in the position. Okay, so this is what is the second example. You can see a box girder to prepare the ducts for pre-stressing steel is left, then formwork, then tensioning operation of the girder, okay, then transporting it, then placing it in place, then to have a bridge. Okay, so that's about the post tensioning systems. Okay, right. So with this, we have come to the end of half of the unit, which is to talk about pre-stressing systems like pre-tensioning and post-tensioning. So both we have completed, right? So from next session onwards, we'll take up analysis of pre-stress. Okay, right. Thank you.